Hi everyone, welcome to the Sky this month for August 2022. My name's Paul Martinaitis and this show is brought to you by the Astronomical Society of South Australia. So thank you for joining me today, I really appreciate it. We've got a lot of interesting things to talk about. In addition to the great deep sky viewing available at this time of year, the main thing happening in the solar system is the opposition of everybody's favourite planet, Saturn. So it's a good opportunity for looking at Saturn now and over the coming several months. And Jupiter, which is coming into opposition in September, is also extremely well placed for observation at the moment as well. So we'll talk more about that. And we'll also talk about some interesting deep sky objects as well as we do our tour of the night sky. So without further ado, let's take a look at the sky for August. So as usual, we'll begin our survey of the sky in the west, where the sky is setting. So this shows you the sky on the 17th of August, so that'll be the beginning of the dark sky period, when the moon won't be interfering, and the time is shown is around 9 p.m. in the evening. So you can see now the constellations that have been a constant companions to us over the last couple of months, such as Vela and Carina. They're well set now, but starting, halfway below the horizon. Virgo and all those galaxies are pretty much setting below the horizon. And also Hydra. You can just see there the longest constellation. You can just see the tail sticking up. However, in Hydra, it's not too late to have one last look at M83, the great face-on spiral in Hydra. So always worth a look out whenever you got the telescope in that region of the sky, and that's still reasonably well placed for observation. Centaurus and Lupus, the wolf, they're still reasonably high as well. And then looking up further towards the zenith, of course we've got the great winter constellations of Sagittarius and Scorpius, very well placed for looking at objects in them right now. And in fact, in the last show, in the July show, I took you through how to find some of the brightest nebula in Sagittarius, such as the Lagoon and the Trifid and the Swan Nebula. So if you missed that last month's show, I invite you to go back and perhaps look at that segment if you want to see some of the objects that you can look at in Sagittarius. And in the previous show to that, in June, I also went through some nice objects in Scorpius as well. So now looking towards the north, we can see that that's dominated by Ophiuchus, the healer. And Ophiuchus is surrounded by the Serpens. And Serpens is unique in that it's the only constellation that's actually split into two distinct regions. So you have Serpens Cauda, the tail, and Serpens Caput, the head. So it's one constellation, but it's split effectively into two regions. And in the middle you have Ophiuchus, the healer. There's also Aquila, the eagle. That's a particularly nice constellation. It's got a nice distinctive pattern. And it's got a whole heap of planetaries in there. At least 12 that I know of. But there would be more. So it's actually possible to spend an entire evening just in Aquila doing a tour of the planetary nebula in there. They're not all bright. Some of them are brighter than others, but with a reasonably sized scope, most of them will give you a reasonable view. So it's for that reason it's got so many planetaries. I sometimes think of it as the Virgo of planetary nebula. But while we're in the north of the sky, I'd like to point out to you three objects that are particularly well placed for northern hemisphere observers, but not so much for us here in the south. But this time of year is the best time that we can observe them because they're pretty much as high as we can get. So the first object I would like to point out is the famous Ring Nebula in Lyra, the Harp. So Lyra is very easy to find. So you can see there to the left we have Hercules, the distinctive figure of Hercules. And then you'll see a bright star Vega, and next to that star you can see this parallelogram of stars here. So you got the Vega, the parallelogram. And if you look in between the two top stars of the parallelogram, if you aim your telescope pretty much bang in the middle, you can't miss the Ring Nebula. It's that easy to find. Even someone who's poor at star hopping like me can do it easily. So that's kind of a simulated view of what the Ring Nebula looks like, perhaps without the colour, through my 12-inch telescope, and the magnification there would be about 190 times. So the Ring Nebula, it's a little bit like the 8 burst, which we've looked at in Vela. It has a nice round shape, looks like a donut, but even more so than the 8 burst nebula, the Ring Nebula really looks like a distinctive donut. So you can see that round, brighter circle, and it has a much darker centre. And again, like most planetary nebula, it responds very strongly to filters, in particular an O3. So on a good night with an O3 filter, with plenty of magnification, that ring will actually look smoky, like you can see here in the picture. So if you can imagine a black and white version of what you see there, that's pretty much what you can see through the eyepiece. It's really an amazing object. Now, the other thing about the Ring Nebula is all of these planetary nebula have a central star. So that's the remnants of the star that puffed off its outer layers in the final stages of its evolution, and those outer layers form the actual planetary nebula. And then inside we're left with a very hot white dwarf, which will cool down over an enormous number of years. So with a nebula like, say, the 8 burst, the central star is readily apparent on most nights. You can just see it right there in the middle. Same with a nebula like, say, the Ghost of Jupiter. Again, you can just see that central star very easily. With the Ring Nebula, it's very difficult to see for two reasons. One is the magnitude of the central star is about 15.2. So against a dark sky background, that would be reasonably easily visible through, say, a 12-inch and above telescope if you use enough magnification. But the problem is you haven't got dark sky behind it. You've actually got that inner region of the nebula. So even though it looks relatively dark compared to the outer edges, it's still much brighter than the night sky, the background sky. So that decreases the contrast, and it makes that central star extremely difficult to see. I've personally never seen it. People have seen it. I've seen reports in a smaller telescope as a 9.25 inch Schmidt-Cassegrain. But so if you've got say a 10-inch telescope or above, certainly take a look at it, look for it, use plenty of magnification, and you might get lucky. You might see it one day. Obviously, the bigger telescope that you have, the more likely it is that you might be able to see it. Now, the next object I'd like to have a look at is in Cygnus. So Cygnus, very, very distinctive constellation. So that's Cygnus the Swan. So you can see there it basically forms this giant cross. The vertical part is the body, the horizontal part are the wings. And it always looks really big to us, or to my eye at least, because we see it close to the horizon as well. So we get that magnification effect. So there's a lot of nice objects in Cygnus. The one in particular, the most famous, is probably the Veil Nebula. So to find the Veil Nebula is quite straightforward. Once you locate the central part of the nebula, you can see the wings come across, and all you need to do is follow from that star there on the body up to these two stars here. And if you imagine this is the base of a triangle, and just complete that triangle, and if you point your telescope sort of here, and we'll zoom in a bit, that's where you'll find the Veil Nebula. So you can see that it's actually very large. I'll just bring up the Telrad circles to give you an idea. So this inner circle is 2 degrees and this outer circle is 4 degrees. So the Veil Nebula is about at least 3 degrees across. So remember that the full moon is half a degree. So this is actually 6 full moon diameters. So very, very large. And so it's actually unlikely you're going to fit, well, you won't, I don't think you will fit all of that in a single field of view unless you have a very, very wide field of view on your telescope. So the idea would be use a relatively wide field eyepiece, try and get one that gives you at least a degree or more field of view, relatively low magnification in other words. Again, a nebula filter such as an O3 will greatly enhance the view. And then what I would do is I would start, so that'll probably be sort of your field of view, something like that. Start on one part of the nebula, and then what you do is you kind of just enjoy scrolling around like so. So you just kind of follow around in a circle to sort of get an idea of the shape. So clearly the star, the central star that exploded, would be somewhere in here. Presumably that left behind a neutron star, I assume, somewhere, which we wouldn't be able to see with our telescopes anyway. So that would be somewhere in the middle here. And then those layers over time have moved outward from the centre. So on a good night, you need an absolutely dark sky, so certainly no moon interference. If you're using a nebula filter, you can see much of the detail that you can see in this image here. You can really see that fine filamentary detail, even from the Southern Hemisphere where we are, where it doesn't really rise extremely high in the sky. So certainly check that out if you've got a good northern horizon to take a look at. And I'll just say too that we're actually extremely privileged in the Southern Hemisphere because, of course, not only can we see the Veil Nebula, but we have the Vela supernova remnant as well in Vela, which we've looked at before, which is a similar kind of thing. It's that sort of large supernova remnant with that filamentary type structure. So we're actually very lucky to have both of those accessible to us. And the final object I would like to take a look at while we're here is the Dumbbell Nebula, or Messier 27, and that's actually in the constellation of Vulpecula, the fox. So Vulpecula is really just a line with a star on each end, but for what it's worth, there's the artwork for Vulpecula the fox. A bit hard to make out the fox from the stars, I think, but there it is anyway. So you're going to find the Dumbbell Nebula pretty much halfway between Vulpecula and this line of stars here, which is Sagitta, the arrow. So this is another planetary nebula, relatively large, quite a bit larger than the Ring Nebula. You can see there that I'll just go back to 190 times. When we looked at the Ring Nebula at this magnification, it was only sort of made up this central portion here. So first thing you'll notice, and this is what surprised me the first time I saw it, how large it is. So you'll notice a really large ball of light, and then this red part forms kind of the dumbbell or a bow tie. So actually in the telescope you will see that very distinctive bow tie sort of effect. A really fascinating planetary nebula. So there's three very prominent normally Northern Hemisphere objects, but particularly well placed this time of year. Okay, now we'll take a look at the eastern part of the sky. So there's Cygnus that we're just looking at here. You can see, we can just see the front of Pegasus just peeking over the horizon. We'll be talking more about that later in the year. So the main constellations in this direction of the sky are Aquarius, there's Capricornus. Not a lot of objects in Capricornus. Probably the main one to note is NGC 7009, or the Saturn Nebula. Since we've been talking about a couple of planetary nebulae already, this is another nice one to contrast with the others. This one is called the Saturn Nebula because I'll just increase the simulated magnification. As we zoom in, it's not a very good rendition, but essentially it looks greenish through the eyepiece, very intense green colour. So you'll see this ball of light. Sometimes you can see some internal detail within that shell, but you'll see these two extensions that you can see there kind of in red. So it's those extensions or antennae that kind of remind you of the planet Saturn, which is why it's called the Saturn Nebula. So quite well placed for observation at the moment. A very bright planetary nebula, but to see that structure you need good seeing, and you need to use a lot of magnification to bring that detail out, if possible. So ironically, right near the Saturn Nebula, of course, that's where Saturn is at the moment as well, which we'll be talking about very shortly. So the other thing is, in this region of the sky, as we sort of head a bit towards more the southeast, is even though we've kind of lost the galaxies over the Virgo side of the sky, over this side of the sky, we're gaining all these great galaxies in Sculptor and Fornax, and we'll be talking about those a bit later on, very shortly, in some upcoming shows. So finally now, moving to the south, and you can see, I'll just zoom out a bit so we get a bit of a better perspective. You remember when we started the show, when I started my shows in the beginning near January, the Southern Cross was kind of over this way, and there's Achernar there. So there's Eridanus, there's Achernar. Achernar was over to the right, so we now come a full half rotation the other way around. And so now the constellations in the south that are really quite well placed for observation are Grus, which we just saw before. Grus, the crane, Indus, and of course Parvo, which has got some nice galaxies, as well as that great globular 6752, which we talked about last time. Okay, so here's the lunar calendar for this month. So the dark sky period, where the moon won't interfere with our deep sky observations, was at the beginning of the month, from the 1st to the 5th. So the next window will open up on the 17th of August and then go through to the 31st and then into early September. So we've got quite a large observing window towards the end there. In between, of course, before the 17th, good opportunity to view the planets, particularly Jupiter and Saturn, double star observation, and of course lunar observation as well. And there I've marked in red, there's the actual date of Saturn's opposition, but of course that's just really a particular position, but Saturn's good to observe, for a good month or more before and after that date. So in terms of darkness, at the beginning, on the 1st of August, darkness began at around 7 o'clock and went through to 5:45 in the morning. By the 31st, the darkness will start a little bit later at 7:20 and go through until 4:45 in the morning. The lunar phases, first quarter will be on the 5th. Full moon will be on the 12th, and like in July, the full moon this month will be a so-called supermoon. Like I explained in the July show, supermoon is just really a technical definition. It means that effectively the moon is going to be a little bit brighter, a little bit larger, but it's nowhere near as special as you might believe from what you read in the media. So if you missed that part, you might want to just go back and have a look at the last show where I talked about the supermoons. Last quarter is on the 19th and new moon is on the 27th. Okay, let's take a look at the solar system. So this shows you the situation at the beginning of the month, and we'll first focus on the interior planets. So let's begin with Venus. So at the beginning, on the 1st of August, Venus was reasonably well placed for observation in the morning. Early morning, but as you can see, as the month draws on, it's getting closer and closer to the sun. So really not a great time for observing Venus. However, Mercury, by mid-month, from about the 15th onwards, becomes an excellent evening object. So it's actually, remember, this is the evening side of the sun, if you like. So that's now an evening object, very well placed for observation from about the 15th onwards, and it gets even better because it's getting further and further away from the sun from our perspective, and in fact it reaches greatest elongation on the 28th of August. So it'll be rising higher and higher in the evening. So just look for it in the western sky just after the sun sets, and you should see it. And that will continue into early September. Okay, so let's take a look at Mars now. So remember, I think we're all looking forward to that opposition of Mars in December. You can see we're certainly getting closer and closer to catching up with Mars. So at the morning, it's still certainly a morning object, getting a little bit brighter. And on the 27th, it actually reaches what we call quadrature. That's a little bit like elongation. What it means is that if we take the Sun, the Earth and Mars, that forms a right angle. So we call that quadrature. And so when you look at Mars, and I'll show you a simulated view of that shortly, you'll actually see that it has a gibbous phase to it, a little bit like the Moon. It won't look like a complete circle. It'll have a partial phase to it. So now turning our attention to some of the outer planets, and what I might do is spin us around just so we can see things a little bit better. So of course on the 15th we have the opposition of Saturn. So that just simply means that the Sun is behind us, we have the Earth, and then Saturn is directly in front, so they form a line. So the practical upshot of that is Saturn will be closest to us, and therefore the largest it will be and the brightest it will be for this apparition. But fortunately for both Jupiter and Saturn, you can get excellent observing for about 2 months before opposition and about 2 months after opposition as well. So opposition just really signifies that optimal point in the middle of that cycle. And moving across a little bit to Jupiter there, that will come into opposition next month. So the Earth would have moved on to about here somewhere. And so Jupiter will come into opposition, and also Neptune as well in September. Okay, let's now look at some of those particular planetary situations that we were talking about. So shown here is the sky looking eastward on the 15th at around 11 p.m. So that's the night of Saturn's opposition. So Saturn would have risen early in the evening, and by 11 p.m. it's actually quite high in the sky in Capricornus. So there it is there. And then lower down in Pisces, by 11 p.m. you'll see Jupiter would have risen to about 20-30 degrees above the horizon, and the Moon will be really nearby as well. So good opportunity to look at all three objects while you're out there. So there's a depiction of the Moon at that time. So we're sort of just after full moon really. So it's a waning gibbous crescent there, and there's Jupiter. The great red spot is not visible at 11 p.m. but it will likely become visible later in the evening as Jupiter rotates around. And around 11 p.m. you can see that all of the Galilean moons of Jupiter are in a line just on one side of the planet. Okay, and that's just a closer look at Saturn on that evening of opposition. So you can see there its moons are making kind of an interesting pattern. Titan, the largest moon, usually has an orangey sort of colour. That's sort of further out, and then you've got the other moons kind of forming a V shape above. So you should be able to see most of these moons. Certainly you'll see Titan, and you should be able to see most of these inner moons. Hyperion is the tough one to see. That has a magnitude of about, I think at the moment, about 14.2, 14.3. So it's roughly the same brightness as Pluto. So not particularly hard to see under a dark sky in, say, a 10-inch or 12-inch telescope, but you certainly know where to look. So that's where some sort of app or tablet can help, running something like, say, Sky Safari, where it can give you the exact position of those faint objects. And one interesting thing you'll find about the moons of Saturn is they don't move as fast as the Galilean moons of Jupiter, but over a period of an entire evening, or even better, several days, they do change configuration a lot. So here again is the alignment on the 15th. And you can see there by the 28th, towards the end of August, completely different. Now they're kind of bunched all over towards one side of Saturn. So you've got all these inner ones kind of bunched up here. And then you've got Titan, Rhea and Ipetus sort of forming a line there on the right. So it's nice to sort of watch them as the months progress, as well as the planet itself. So here's just a picture. So this is actually a picture that I took myself in, I think, 2020, around opposition. It's not a particularly sharp photo, but I chose it because it kind of shows you what a good view of Saturn can look like through an eyepiece, just much smaller. And I thought I'd just point out a few features that you should look at when you're looking at Saturn in the eyepiece. So, of course, no matter how bad the conditions are, you're going to hopefully see the planet, you'll see the rings, and then depending on how steady the atmosphere is and how much magnification you can use, you can certainly see some additional features. So the first additional feature that you should notice on a reasonable night is that gap in the ring. So that's called the Cassini division. Sometimes on a wavery night it might come and go a little bit, but on a nice steady night it can actually appear razor sharp, even sharper than what I've shown you here in this photograph. Some other things you can look out for are this interior ring here. So inside this bright ring here, there's kind of a darker ring. It's not as dark as the background sky. It's just a little bit lighter. So that's sometimes called the crepe ring. So take a look for that as well. Look out for that. Of course, you can see banding on the planet's surface, and that's one of the advantages that aperture brings to Saturn. So if you're looking at it, say, for a 10-12 inch telescope on a nice steady night, these bands really become sharp, and you can see all those, beautiful pastel colours, a little bit like you see here in the photo. So they're much more subtle colours than what you'll see on Jupiter. Another thing to look out for, you'll see you'll usually see the shadow on the rings. So that shadow there is caused by the planet itself casting a shadow on the rings. So that will usually looks extremely sharp. And finally, up the top there, see if you can spot the pole. So in this photograph, you can see that polar region is really just a bit of a green dot. But I've shown you in this inset here, that's a picture from the Cassini space probe taken when it flew over that region. And you can see that pole is a hexagon shape due to some sort of resonance effect. It's really, really fascinating that it can hold such a shape, and it's done so for decades now, as far as we know, maybe even longer. So occasionally you can kind of see that in the eyepiece. So what you'll see is we're seeing it much more edge on, but you can kind of perceive sort of a straightness. You can tell that it's not quite round. So on a really good night, use plenty of magnification on that region if you can. And if you've got a fairly big telescope, you might be able to discern its shape a little bit as well. Above all, though, make sure you enjoy the view. That's the main thing. Okay, and finally, like I mentioned, Mercury from mid-August through to through into September is excellent viewing because its effective distance is large from the sun, so we can allow the sun to set and it's not lost in that really bright twilight. So this shows a nice view on the 30th of August at around 6:30 p.m. in the evening. And that time you'll see Mercury. So wait until the sun kind of just sets, then you should see Mercury, and then you'll see the moon close by as well. And at this time they make nice crescents, so you can see there that Mercury, just having passed its greatest elongation, should show pretty much a half phase. So you would be able to see that in any telescope, and you can even see it in binoculars. You'll just need to either steady your hands against a car bonnet or a wall, or even better if you can mount your binoculars on a tripod. And the moon is now going to be a very, very lovely thin waning crescent. Thank you everyone for joining me in today's show. I hope you found the information useful. Let's hope we get some good weather so that you can get out and enjoy looking at Jupiter, Saturn, the moon, of course, and all the wonderful deep sky objects that are available this time of year. So I look forward to seeing you in the September show. Until then, clear skies and bye for now.